Hello. I am out today. I've got to take my son into the clinic this morning. So I'm here at it's like, I don't know, 5:45 or so. And I'm just getting you guys set up with an activity for today. And it's on the speed of sound. So if you're on this document, and hopefully you've already clicked the watch this because you couldn't see me without clicking that. But I want you to scroll down to where it says speed of sound. And then there's these web resources. And the one we want to go to is called the Physics Classroom on Sound. And go ahead and open this up. Now there's a few different parts of this website that I'd like you to go to. So essentially this is like a textbook on sound. So the first one we want to do is this click on the speed of sound. And it'll actually talk about how we actually go through speed of sounds and what are some things that make sound travel at different speeds itself. And then there's this part here where it corrects for temperature, and you'll want to kind of look over and read this over because that'll be something you'll need to do for today. Okay, so this is the speed of sound one. The other link that you'll need to look at here for today will be on closed-ended air columns and open-ended air columns. I'm just going to click on the closed-end columns first because that's what we're using today. We're going to be using a tube that's going to make a closed, or that will be closed on one end by having water on it, and then open on the other end. And what we're going to do is we're going to get our wavelengths to go in there, and we'll look for our fundamental, which will be 1/4 of that wavelength. Now there is a correction for diameter as well, and I'm looking here and I don't see it on here, but I think I talked about it on the topic set instead. So if you scroll down here, you can see that we're going to be talking about the speed of sound, and here's the length or an adjusted length is based off of this little equation right here. So you'll be able to use multiple tuning forks, measure the length of the column of air, adjust that length of the column of air due to the diameter, and then calculate the wavelength based on that column, and then calculate a speed of sound. And you should be able to then, after you know the temperature of the room, be able to make that adjustment as well. So here it goes. I'm just going to give a quick little demonstration of how to do this activity. So you can see that I've got my column and I've got my adjustable column here. I grabbed a couple of tuning forks. So I'm just going to take a tuning fork and you hold it above until resonance occurs. So that's pretty good sound there. So it's like I've got a resonance point right there. I also had one, I think, back here. But that's not the fundamental. That's the fundamental. So I'd keep that. And then I can do another one right here. So that's where I then look at this and I measure this length right here. And that would be my length that I would put in there. The diameter of the tube would give me further correction. And so I should be able to calculate a speed of sound. Now again, when I go through and after I get all of this done in my notebook, I should be able to click on this link right here for the speed of sound and then answer the questions that go along with that. And that's the activity for today. So you'll do the speed of sound activity. When you're done with the speed of sound activity, I did update the practice problems. So there's practice problems that you can start working on right here, the 9 for simple harmonic motion, and we've got some for waves, and then some for sound waves. So you should be able to go ahead and start doing some of those practice problems, and they are right here. It's practice set 8, and so that's what you'll be working on today. Hope everything goes well today. If you do have any issues or concerns, I'll try to have the topic set 8 document open so that I can see over here on the chat side of if you have any questions. All right. Good luck, and we will see you tomorrow, and we'll probably start talking about and light and optics. Okay.